Today we're on lesson 3.7, and you can see our topic today is quadratic inequalities. We've been spending quite a bit of time on solving quadratic equations, graphing quadratic equations, and some of that's going to be useful in today's lesson, but the focus now is on inequalities, as you can see. So my two big takeaways from this lesson: I want you to be able to graph quadratic inequalities in two variables. And then we're going to go from there and solve quadratic inequalities in one variable. So let's just take a look. There's really three different types of problems that you're going to be dealing with in this assignment. So let's take a look at this this first example, 1A. This is what you're going to do on problems 14 to 18 even. It's a review of graphing quadratic equations, getting the parabola, and then the inequality will tell us how to shade either inside the parabola or outside. So first of all, let's just go back and remember how to come up with the graph of the equation y equals x squared plus 2x plus 4. And you've learned now to change this into vertex form. So if you don't want to have to do the opposite of b over 2a formula to find the vertex, you can always use vertex form. I think it's a lot better to graph with. I'm going to divide 2 by 2. Okay, 1 squared is 1, and remember, just take the minus 1 in this case and just tack it onto the end of your standard form and put those two numbers together, and you'll complete vertex form. So the vertex is -1, 3. So I'm going to start by plotting that point, -1, 3. Another easy point to plot, looking at standard form, is the y-intercept, and that's 4, which means my symmetry line being x equals -1 helps me come up with other points that correspond to other points on the graph. And now just another input, like for example input 1, and for an input 1 I get 1 plus 2, which is 3, plus 4 is 7. So the point 1, 7 is also on the graph, and match that up using the AOS. Alright, and so now I'm ready to sketch the graph, but remember when we were talking about graphing linear inequalities, if it is or equal to, then that's a solid, it was a solid line. If it was not or equal to, then it was a dotted line, and that same principle is true with our parabolas. Since this says or equal to, then I'm going to have a solid U shape. And we'll look at an example in just a moment where it's going to be dotted. Okay, now remember the shading principles that we talked about when we did absolute value V shapes. And we said less than was below the line, in this case both lines, and greater than is above the line, which would be inside. And you can think that same way when you're shading the parabolas. Less than indicates below or outside of the parabola that opens up. So we're going to be shading everything outside of this parabola that opens up forever. And some people suggest, and I think it's a good idea, you can always make sure that you shaded correctly just by picking a point. Just pick any point in your shading and see if it makes this blue inequality a true statement. And a pretty easy point to use as a test is the origin, because x is 0 and y is 0. So let's go up to this blue inequality, and if we substitute 0 in for y and 0 in for x, do we get a true statement? Is 0 less than or equal to 4? Well, obviously it is, and so now we have some assurance that if 0, 0 is in the shading, then and it's true, then all of the other points in the shading will also be true when they are substituted in for x and y. Alright, so that is your answer for example 1a. Let's try another one of these. Here's another inequality. I like to personally turn these around so that y is first, not necessarily that you have to do that, but just be careful, since I'm pointing at the quadratic. When I turn it around, I should still be pointing at the quadratic with this inequality symbol. Alright, so I just turned it around, and so let's just go about the routine of graphing as though we were doing the equation y equals x squared plus 6x minus 2. And once again, I'm going to use vertex form, x plus 3, 6 divided by 2. 3 squared is 9, and I just brought 9 up here and subtracted, and you put those together and you get negative 11. So my vertex is negative 3, negative 11. 2, 4, 6, 8, 10, and 11, if I counted right. 2, 4, 6, 8. Yep. Alright, and let's just go ahead and grab the y-intercept is negative 2. Okay, I have symmetry here at negative 3. X is negative 3, so I can match that up. Just another input. Let's just input negative 2. And you can put that into either vertex form or standard form. I think vertex form is a little bit easier because you only input once instead of twice. So let's let x be negative 2. Negative 2 plus 3 is 1. 1 squared is 1. And 1 minus 11 is negative 10. So negative 2, negative 10. And because of symmetry, I can match it up. Now this time, because it doesn't say or equal to, I'm going to be sketching a dotted parabola. And if you want to draw the solid and then just erase part of it, obviously that would be okay. Okay, and notice we're saying greater than. Y is greater than. So greater than for this quadratic, hit the wrong button, greater than is above the line, or for a parabola that opens up, it would be inside the U shape. And once again, if you want some assurance, you can pick an ordered pair that's in your shading and see if it works. And if that point works, then the other points in the shading should also be true. Now remember, in this case, we cannot choose ordered pairs actually on the parabola because it has to be just greater than, not or equal to. So once again, looks like the origin falls in the shading. So if we test the origin, does it make a true statement? Let's see, 0 is greater than 0 plus 0 minus 2. Is 0 greater than negative 2? Certainly is. And so therefore, since my origin, which is in the shading, works, then the other points that fall in the shading should also work. Alright, let's try this one. One more example, and then we'll move on to a different type of problem. So think about the equation y equals negative x squared minus 7x plus 8. I wanted to show you this one because we haven't talked yet about changing to vertex form when this number in front of x squared is something besides 1. Like in this case, it's negative 1. Or what do we do when it's something bigger than 1? We're going to talk about that later, but I thought I'd just go ahead and show you it's not too bad when the coefficient of x squared is negative 1. We're just going to do a little temporary change. Just think of dividing by negative 1 on both sides. Remember, before you can complete the square, we need to make this become positive 1. So in effect, I just divided everything by -1 on both sides of the equation. So let's just go ahead and go through our routine. X plus 7/2, and 7/2 squared is 49/4. So I'm going to come over here and subtract 49/4. And remember, 8 is another way of saying, if we're talking about fourths, that's 32/4. So we're basically going to be subtracting, it's -32/4 minus 49/4, and that's -81/4. Okay, well, your final vertex form should be solved for positive y. So let's just put it back, multiplying by -1. And that's going to make this number in front of the parentheses, which we call a, just like up here in standard form we call that number a in front of x squared. It's going to make a negative. Nothing changes in the parentheses. But this number out here that we call c in vertex form, it will also change. It will become positive. Okay, so just a little different when the number in front of x squared in this case is -1. But my vertex is found the same way. It's -7/2, positive 81/4. Well, since this is a little bit more than 20 1/4, I'm going to make my y-axis in 2s. Don't think it's really necessary to change the x-axis. So let's just go ahead and plot this -3.5, and then 20, 2, 4, 6, 8, 10, 12, 14, 16, 20, and then just a little bit more. I'm going to erase some of my work here because we'll need some graphing space, but hopefully you saw how you have it written down how we changed to vertex form. Okay, we have a positive 8, 2, 4, 6, 8 y-intercept. So that's 3.5, so 1, 2, 3. And then another input. We can do just about anything we want. What about -2? We'll just go back, since I've erased vertex form, we'll just use the standard form. Alright, so -2 squared is 4. That makes -4 plus 14 plus 8. So -4 plus 14 is 10, and 10 plus 8 is 18. So for -2, we get 2, 4, 6, 8, 10, 12, 14, 16, 18. And that's 1.5 to the right, so we'll do 1.5 to the left, matching that up. So here is the parabola opening upside down because a is negative. And now let's do the shading. Less than is below the line, and for the parabola that opens down, now we're talking about inside the parabola. And the parabola should say solid because it says or equal to, so it will not be a dotted parabola. And so once again, let's just do a little test. No reason to ever miss these because it's easy to check. You can even do a mental check. And once again, I'm just going to use the origin because that's easy math. If I let y be 0 and x be 0, I get 0 is less than or equal to 8. And that is true. So I have shaded the correct area, because if the origin is in the shade and it works, then the other points that are in the shade should also work.